So as a crash course, just try to understand very quickly that what are the three different cases to write the complementary equations of the second order differential equations. So in case number 1, if the factors means after writing the differential equation in terms of m, your factors the m1 and m2 are different. Okay, so they both are the different, then in this case the y complement will be written as c1 e to the power m1x plus c2 e to the power m2x. Now in case number 2, if m1 and m2 are same, it means the factor is has a multiplicity of 2, then you can write it as y complementary equals to c1 e to the power m1x plus c2x e to the power m1x. Why I am writing m1 both time? Because they both are same. Now in the third case, if we get the complex solution, it means alpha plus beta I. So in that case, you write e to the power alpha x, in the bracket write c1 cos beta x plus c2 sine beta x. So keeping these things in the mind, we have to write our solution for the second order differential equation. So let's try to solve some of the questions. So y double prime minus 5y prime plus 6 equals to 0. So first of all, convert them in the form of m. So double prime will be converted as the power of 2. Single prime will be converted as m, and y will be as a constant. So we can write it as m square minus 5m plus 6 equals to 0. Factor them. You can use your scientific calculator, and in the scientific calculator you can use directly mod 5 and 3. And if not, then we know that the factors are m minus 3 and m minus 2 equals to 0, or in your calculator it would be directly as m equals to 3 and m equals to 2. So it is the first case because the m1 and the m2 values are different. So for that reason we can write y equals to e to the power mx, that means 3x, c1 e to the power m1x plus c2 and e to the power m2x, that means 2x. So this is how we represent our case 1. In our case 2, again the first thing is convert them and write them in terms of m. So m square minus 6m plus 9 equals to 0. Use again mod 5 3, you will get m equals to 3, and you have to write 1 minus 6 and plus 9. But if I factor them here, I can get m minus 3 and m minus 3 equals to 0, which means I can write it as m minus 3 whole square equals to 0, or m equals to 3, and 3 has a multiplicity of 2, which means 3 you have to write 2 times. So your equation will be c1 e to the power 3x plus c2x e to the power 3x. We have to differentiate them, the two terms. That's why first time we don't write the x, and then the second time we are writing the x. So let's check the third kind of the equation. So first of all, write down in the form of m squared plus 8m plus 25 equals to 0. Now try to factor with the help of the calculator or use the quadratic equation to factor them. And after that you will see that your factors will be m equals to minus 4 plus minus 3i. Okay, so here it is very clear that you have got the complex quotients written in the form of alpha plus beta I. So alpha is the real part, and the real part is -4, and beta is the imaginary part, that is 3. So we know that how can we write our equation looks like e to the power alpha x c1 cos beta x plus c2 sine beta x. So this is the form we are looking for. So e to the power alpha is -4 x c1 cos of beta means 3x plus c2 sine of 3x. So this is how we write our question in which the roots are complex. So if you understood these things, so let's go to the questions which are given in the which come in the in some of the final exams. So let's start solving some of the questions containing the second order differential equation. So the first thing is that we have to focus that we can see that this equation is in the form of variation of parameters. Why? Because for the variation of parameters, the equations are written in the form of a y double prime plus by prime plus cy equals to some g of x. So if this is the form of the equation, so we can solve it with the help of the variation of parameters method. Now in the variation of parameter, also understand that y equals to y complementary plus y particular solutions. Now for the y complementary, we already have seen in the same video how to find out the y complement, and for the particular solution we will use our Wronski method. But before that, doing the Wronski method for the particular solution, let's find out the y of c. So for that reason, solving for yc, that means y complementary, what you have to do, you have to convert the y double prime into m square. It will be minus 2m plus 1 equals to 0. Now on factoring, you will get y equals to 1 with the multiplicity of 2. That means m equals to 1 and m equals to 1, which means that both the roots are same. So we can write here y of c equals to c1 e to the power mx, that means the 1x, so we don't write the 1, so it is x, plus c2x e to the power mx, because both the forms are same. So this is how we write our complementary solution. Okay, so now let's check how can we solve for the particular solution. So solving for yp, so solving for yp, now let's have a look. So for yp, first of all, write down the Wronski equation. So for Wronski, we should know that the first column is our y1, and our y1 is e to the power x, and in the second column it will be our second y2, that is x e to the power of x. And in the second row, we will write the derivatives of the first row. So the derivative of e power x is e power x, and derivative of x e to the power x can be done with the help of product rule. So I am showing you here x e to the power x. We will use our product rule, that means f and g. So our answer is fg prime plus gf prime. Our f is x and g prime is e power x, g is ex, and f prime is 1. So we will write here, that is x e to the power x plus e to the power x. Now we have to solve them, and that is AD minus BC. Okay, so the determinant is equals to AD, that is, this is A, this is D, and minus BC. So our AD, it will be e to the power x times x e to the power x plus e to the power x minus BC. So this is our BC. So BC will be x e to the power x times e to the power of x. Let's try to solve them. So first of all, open that. So e to the power x, x times e to the power 2x. Why 2x? Because e and e, both the bases are same. So we add the powers. Plus e to the power 2x, because e to the power x times e to the power x. E power x times e power x, it gives me e to the power 2x. Reason is that I add the powers. Minus x e to the power 2x. Now x e to the power 2x and x e to the power 2x will be cancelled out because they both are same with different sign. So our w is e to the power of 2x. Now after that, let's try to find out w1. So for w1, what do we do? The first column will be replaced by the first column, first row, that is 0. And in the first column, second row, we will write down this g of x. That is e to the power t to the power negative 1 e to the power 2 t. Since from the beginning I am keep writing xx, so right now I am just converting this xt into x only, because from the beginning I made that mistake. Rather than writing t, I wrote x. So no problem, it will not affect your answer. Okay, so the second question, second column stay the same, that is x e to the power x and x e to the power x plus e to the power x. Now our thing is that AD, so anything multiplied by 0 gives me 0, minus BC, that means x e to the power x times x to the power negative 1 e to the power x. Now x and x, so I'm showing you here x and x to the power negative 1 are same. So if we add the bases, we will get x to the power 0, which gives me in the end 1. So I have been left with e to the power x times e to the power x, means e to the power of 2x with this negative sign. So the last thing is, that is Vronsky number 2. I will find out Vronsky 2 by keeping my first column of the actual Vronsky as it is, by change the second column of the Vronsky by 0 and g of x, that is x to the power negative 1 e to the power of x. Now AD minus BC, so our AD will be e to the power x times x to the power negative 1 e to the power x minus 0, because anything multiplied by 0 is 0. So in the end, I will get e to the power 2x x to the power of negative 1 as Vronsky number 2. So now we know that y particular, it is u1 y1 plus u2 of y2. Now what is u2 prime? So u2 prime, it is Vronsky 1 over Vronsky, and u1, sorry, this is u1 prime, and your u2 prime is w2 over w1. So your w1 is negative e to the power 2x and your w is e to the power 2x. So they are cancelled. The answer u1 prime is negative 1. Okay, so now our u2 prime. So u2 prime equals to W2, that is x to the power negative 1 e to the power 2x over W, that is e to the power 2x. So in the end we will get U2 prime as x to the power negative 1, or it is also equals to 1 over x. So now find U2 and U1 by integrating it. So U1 equals to integral of minus 1 dx. So U1 equals to minus x plus c. Similarly, U2 equals to integral of 1 over x dx, and antiderivative of 1 over x is ln of x plus c. Now put all these data into the YP. So YP equals to U1 is minus x plus c e to the power of x plus c, and Y1 is e to the power of x plus U2, that means ln of x plus c, and x e to the power of x. You can open, distribute, and that's it. So you will get negative x e to the power x plus c e to the power of x plus x e to the power of x ln of x plus cx e to the power of x. Now for y, we have yc plus yp. So yc, you can see from the back that it is e to the power of x, c1 e to the power of x plus c2 e to the power of x plus yp, that means minus x e to the power of x plus c e to the power of x plus x e to the power of x ln of x plus cx e to the power of x. Now we can just combine all, yani take the e power x as the common factor before finalizing our answer. Otherwise, this is your final answer. So we know that in order to find out the particular solution of second order differential equations, we have to use different kind of the methods, among which the variation of parameters and the finding and the undetermined coefficients, parameters, and finding or solving the differential equations using undetermined coefficients are the most important and popular methods. Okay, so the question comes that when do we use the variation of parameters method and when do we use the undetermined coefficients to find out the y particular solution. Okay, so the first thing is variation of parameters you will use if you will have such means, for example, if you have the equations, any second order differential equation is written, but on the right hand side you have the equations like t or x to the power of 6 or e to the power of something together are written. So for example 5 t is written or something like that, or you will have the secant of t or secant of x, or you will have the tangent of x, or you will have the, for example, you will have the t to the power of -1, or you might have the e yani something with the e power is written with along with the t having a power 4, for example, and they are raised by a very big power. So in such cases we use the variation of parameters formula, in which we find out the w, w1 and W2, that means the Vronsky, to find out the answer. Now, in undetermined coefficients, I have we can write it. For example, if any constant value is written, okay, so any constant value, for example, any number is written, so you have to use A as the undetermined coefficient on the right hand side. If ax square is written, means any number with the x square is written, you will write ax square plus bx plus c. If some ax cube, bx and some c is written, in that case you will use ax cube plus bx square plus cx plus d, means that from the highest degree to the lowest degree. If something is written with a e to the power of bx, for example, so you will write a e to the power same b of x. But if before the e to the power of bx some equation, polynomial function is written, so if polynomial function is written with ax plus b, so you will write ax plus b and then e to the power of same power. Similarly, and so on. So these are the ways where I have studied and found for you from the internet to solve such to solve the standard undetermined coefficients. Let's try and understand when do we use which kind of method. So now see that how can we solve these questions, and whether we are going to use the undetermined coefficients method or the variation parameter. So you can see from the right hand side that the equation is written in the form of something with e to the power and some polynomial function with the exponential function. So it is very clear that here we are going to use our undetermined coefficients method. Okay, now the first thing is that we have to find out our y complement, and in order to find out our y complement, we have to write the equation in the form of m square, where there is a double prime and then y prime will be converted into the m, and the 9y will be converted only into the 9 as a coefficient, equals to 0. Now factorize it, and on factorization you will get the solution of m as -3 with the multiplicity of 2. You can use the scientific calculator mod 53, write down the a value as 1, b value as 6 and c value as 9 to get the value of m. So you have the two factors, that is m1 and m2, and both are -3. So I'm writing here -3 two times. Okay, so now y complement will be written as e to the power c1 e to the power of the first -3x, that means m1x, and the other one will be written as c2 e to the power of -3x. Since the second factor is also -3x, so to differentiate both the terms, we will write here x. Now x. Now let's try to solve for the y particular. And for that reason, we have to look at the right hand side. And on the right hand side, the first term is 4e to the power of -3x. So I can write it as a e to the power of -3x. But if I just compare what I have written with my complementary solutions of the y, I will see that there is already c1, which is an arbitrary constant, with e to the power of -3x. So it means I cannot write the another constant, which could be anything, with the same function. So now if I write here x, Okay, means I will write here ax. So you can see that on the second hand, on the other hand, I wrote c2x e to the power of minus x, which means this is also not my solution. I can't write like that. So the only option I could write is ax square e to the power of minus 3x. Now plus, now the second one, 5x e to the power of 2x. So because the polynomial function is 5x, so I can write it as bx plus c, because from the highest degree of the polynomial to the lowest degree, and e to the power of 2x will stay as it is. Now I am set with everything. So this is all equals to y. Open the bracket and then differentiate the equation. So I will get here ax square e to the power of minus 3x plus bx e to the power of 2x plus c e to the power of 2x. So this is my first equation. Now I will take the derivative. Now in order to take the derivative of the first term, I can see that here I have to apply my product rule. And according to that I have the f, which is ax square, and my g is e to the power of minus 3x. So my f prime will be 2ax and my g prime will be negative 3 e to the power of negative 3x. So for your information and just to refresh your mind, in order to differentiate e to the power of minus 3x, I applied the derivative rule e to the power u, which is equals to e to the power of u and u prime. So I am writing this over here, my f, that is ax square, and g prime is minus 3. So I'm writing in the front e to the power of minus 3x plus g, that means e to the power of minus 3x. F prime is 2ax. Now have a look on the second term. Again I have to apply my product rule. So according to that, I have my f, which is bx, and my g is e to the power of 2x. So my f prime will be the b and g prime will be 2e to the power of 2x. So applying the product rule, I will write f, that is bx, g prime, that means here 2e to the power of 2x, plus g, that means e to the power of 2x, and f prime is my b. Plus the last term is the direct term because c is a constant, so I can write 2c e to the power of 2x. After doing this, I have to take one more time the derivative. So if I take the derivative one more time, so what I will get, let me clear the screen first. So that I can be able to show you the next working. Okay. So in the first term, I have my f, and again I will use my product rule, and in my product rule I will use minus 3ax square as my f and g with the e minus 3x. So here f, I'm showing you over here, that is f equals to minus 3ax square, and my g is e to the power of minus 3x. So my f prime will be minus, because x is square, so I will use the power rule, so minus 6ax, and my g prime will be minus 3e to the power of minus 3x. So here I will apply f product rule. So my f as it is minus 3ax square, g prime will be minus 3e to the power of minus 3x. So minus 3 times minus 3 gives me 9, positive 9. And be careful and concentrate fully to avoid the mistakes. Okay, so then I have gf prime. So fg prime I am done. Now I have gf prime. So my g is e to the power of minus 3x and f prime is minus 6ax. So I will write here minus 6ax. Okay, now second thing, that is 2ax e to the power of minus 3x. You can see again I can apply my product rule. So here my f will be, on this side my f will be 2ax. So my f prime will be 2a, and my g is same as already I have written, e to the power of minus 3x. So now let's write here. So f g prime. So I will write f, that is 2ax, g prime. So all the informations are here. Let's write it down. The final answer, that y equals to y complement plus y particular solution. So yc is c1 e to the power of minus 3x plus c2x e to the power of minus 3x as written here on the top. And my y is here, yp is here. So in place of a, I can write 2ax square e to the power of minus 3x. In place of b, I will write 1 over 5x e to the power of 2x. And the c is minus 2 over 25 e to the power of 2x. So this is my final answer for this question. Okay, so here there is another question. Here y double prime plus 4y equals to sine 2x. So first of all, we have to find out the complementary solution. So for that reason, we convert the double prime into single m square. We don't have any y prime, so m square plus 4 equals to 0. If you write it in the scientific calculator, 1, the value of a is 1, b is 0 and c is 4, you will get the two values of the m, that is plus minus 2i. And we know that whenever we have any complex solution in the form of alpha plus beta I, to write this equation we always use e to the power of alpha x c1 cos beta x plus c2 sine beta x. Right? So this is the way we show our complementary solution. Now here our alpha is already 0. Alpha is the real part. So over here if we see, our alpha is 0 because there is no real number. So e to the power of 0x or e to the power of 0, yani anything with a power 0, our answer is 1. So this is already 1. We won't write it. We will directly write here. C1 cosine of beta. Beta is this imaginary number, that is 2x, plus c2 sine of 2x. So this is my complementary solution. Now let's see. First of all, understand how can we use and find out our particular solution. Now as we already know that in order to write the particular solution, first of all, we have to understand that which solution or which method I will use. Here, whenever you have the sine, cosine, polynomial function or e to the power of something, then I always use the method of undetermined coefficients. Undetermined coefficients. Otherwise, I will go for the variation of parameter or Wronski equations. I will write in that form. But right now, I will use the undetermined coefficient method. So I can see that here, this sine 2x, it is written in the form of like a or something like that, 5 cos 2x. It is given in the example, in one of the example, that if here sine or cosine is written, you can write your equation as a cosine of that angle which is already given in the equation and b sine of the same angle. So here we have sine 2x. So I can write here my yp or y equals to a cosine of 2x plus b of sine 2x. But what I can see over here when I just compare my particular solution with my complementary solution, I can say that cos 2x already written with some arbitrary constant. Similarly, sin 2x is already written with some arbitrary constant. So I am not allowed to write the same figures, same functions with another kind of arbitrary constants like I'm using over here a and b. So in order to differentiate them, you write here ax cosine of 2x and bx of sine of 2x. Not x, it is sine of 2x. Now this is the perfect thing, so I will just try to write it more. So let's try to take the derivatives of these functions. So as we know, so let me write here that our yc equals to c1 cosine of 2x plus c2 sine of 2x, and now we are working on our y of p. So in order to write our y of p, we have decided that we will write ax cosine of 2x plus bx sine of 2x. Now take the derivative of this function using the product rule. Now for the product rule, our f will be ax, so f prime will be a. Our g is cosine 2x, it is a chain rule, so derivative of cosine is negative sine 2x, and the inner function 2x, the derivative is 2. So here we will apply the product rule, that is fg prime plus gf prime. So write down f, that is ax, g prime, it is negative 2, it is negative 2 sine 2x, plus g, that is cosine 2x, and f prime is only a. Same way we have to do it with the second term, that is your f is your bx, and f prime will be the b, and your g is sine 2x, and derivative of sine is cosine 2x, and the inner function's derivative is 2. So applying that product rule again, we will write f, that is bx, g prime, that is 2 cosine 2x, plus g, that is cosine 2x, that is sine 2x, sorry. G is our sine 2x, and f prime is our b. Now take again the derivative, means the double derivative. Again here we will apply the product rule. So I am doing it directly. You can see here the derivative of fg prime plus gf prime. So I am writing here f, that is minus 2ax, g prime, that is cos sine 2x, it is changes into cosine 2x times 2. That means I will get it here, negative 2 times 2 gives me 4, and here cosine 2x, plus gf prime. So my g is sine 2x, and my f prime will be minus 2a. So it will gives me minus 2a. Okay, so now here I have a cos 2x, so it will gives me only 2a sine 2x with the negative sign, because the derivative of cosine is negative sign. So I have to write here what? My negative sign. Okay, 2bx cos 2x. So here again I will use my product rule, fg prime. So my f is 2bx and g prime is negative 2 sine 2x. So I have to write here negative 2 sine 2x. So negative 2 times negative 2 times 2 gives me negative 4 and sine 2x. So fg prime plus gf prime. So g is cosine 2x f prime will be my 2b. Now my last term, that is b sine 2x, so I will get here 2b cosine 2x. Now let me just check quickly. So the first term is f and g prime will be negative. Okay, so what mistake I am doing, let me show you. Sine is cosine. Okay, so that's right. Plus g, and that is minus 2a. Then here I have negative 2a sine 2x, correct. Then I have minus 4b sine 2x and 2b cosine 2x plus 2b sine cosine 2x. Okay, so all set. Now I will put all these information in my original equation to compare my left hand side terms with the right hand side terms. But same way, let me write. So first y double prime. Look here, it is written y double prime plus 4y equals to sine 2x. So I will gather and I will write all my informations. Y double prime, I have minus 4ax cosine 2x minus 2a sine 2x, and here also 2a sine 2x gives me minus 4a sine 2x. Okay, so then I have 4b minus 4bx sine 2x. Then I have 2b cosine 2x, 2b cosine 2x, it gives me 4b cosine 2x. Then I have plus 4y. So with all my y terms, I have to multiply with the 4. So I will get plus 4ax cosine 2x. And then I have another bx sine 2x, that means 4bx sine 2x. And this is all equals to my sine 2x. So you can see that 4ax cosine 2x and 4ax cosine 2x both are same with the different sign. This cancel and this would also cancel. So now I have been left with minus 4a, this is sine 2x, minus 4a sine 2x plus 4b cosine 2x equals to sine 2x. Now compare them. So here sine 2x, here sine 2x. So I can compare the coefficients. So I will get minus 4a equals to 1. So a equals to negative 1 over 4. This is my a value. Now cosine 2x, there is no cosine 2x on the right hand side. So I can write here 4b equals to 0. So b equals to 0. Now I have the a and the b values. I will go on the top, and in my y particular values, in place of a, I will write here negative 1 over 4, and in place of b, I will write 0, so that this whole term will go on by the 0. Now my final answer is y equals to yc plus yp. So I can write here y equals to yc is c1 cosine 2x plus c2 sine 2x plus negative 1 over 4 cosine 2x. So this is my final answer. Now in this question, although it is written that use the undetermined coefficient method to solve the following differential equation, but you can also see, even if it is not written, you can see that here e to the power of something is written. So of course you should use the undetermined coefficient method. So the first thing is that we have to find out the y complement. That for that reason, convert the y to the power. Y has been a fourth derivative, so you can write it as m to the power 4 minus m square equals to 0. Now here, of course, you have to do some of the work manually. So take the m square common. look, here we have 4m's, right? Here we have 4m and here we have 2m. So it means 2m are common. So we can write here m square common. Now how many m's left? 2. That means m square minus, already the m's are outside. So please write down the one. Most of the students, they forget to write the one, that makes problem later on for themselves. Now one time m square equals to 0 and one time m square minus 1 equals to 0. M square equals to 0, it means you have the two m's, m1 and m2, and both answer is 0. Because of the square, we must have the two answers. Now here also, you bring the m square here, negative 1 over there, so it gives me m square equals to 1. Take the square root on both sides, you will get plus minus 1 answer. So 1m3, it is negative 1 for example, and m4, it is your positive 1. Now write down the equation yc equals to. Now whenever we have the zeros, so we can write here as c1 plus c2, but since both are the zeros, so we have to write down the t, because it is the way we write for the constant, the numbers, plus c3 e to the power, so m3 is negative 1, so e to the power of negative t, plus c4 e to the power of t. So this is the way we write our complementary solution. Now for our next particular solution, we have e to the power of 2t. So it means we can write it as a e to the power of 2t. Now take the derivative of this equation, and we have to take 4 times the derivatives, okay, because it has y to the power of y with the 4th degree of derivative. It means 4 times you have to take the derivatives. So here we will use the formula e to the power u. The derivative is e power u prime. So your u is 2t. So the derivative of 2t is 2. So we will have 2a e to the power of 2t. Then y double prime, it will be 4a e to the power of 2t. The third prime will be 4 times 2, 8a e to the power of 2t. And the fourth time, if you take the fourth derivative, you will get 16a e to the power of 2t. Now write it in your main equation. So y having a 4th degree power, so you will write here 16a e to the power of 2t. Then minus y double prime, that is 4a e to the power of 2t equals to e to the power of 2t. Now here 16a minus 4a, it will gives me 12a e to the power of 2t equals to e to the power of 2t, which means that 12a equals to 1. Don't write the coefficient at 0, it is 1, because here there is no number, which means 1. So a equals to 1 over 12. Now write it in the particular solution. So you will get y of p here. In place of a, we will write 1 over 12. Now finally we have y of c equals to y of c plus y of p. So here y of c is already, we have found that c1 plus c2t plus c3 e to the power of minus t plus c4 e to the power of t plus yp is here. That is 1 over 12 e to the power of 2t. So that is our final answer. Having a look on this equation, although it is written variation of parameter use, but you can find out yourself also. Look here. If here tangent secant t to the power of negative 1 or 1 over t square or something like that is written, we have to use the variation of parameters equation. So first of all, write down the y of c, which is m square plus 1 equals to 0. So we will get here m square equals to -1. Taking the square root on both sides, we will get plus minus I. You can use the scientific calculator also. It means the equation is written in the form of complex numbers. So our alpha, in our case, there is no real number, so it is 0, and our beta is 1. So we can write here C1, y of complement is C1 cosine of beta t, that means only t, plus C2 sine of beta t, that is t. Now I didn't write here e to the power alpha x, the reason is my alpha is 0. Now I will try to find out my y of p by using the Vronsky. So W equals to, in the first one, we write here y1 and here we write the y2. So our y1 is cosine of t and our y2 is sine of t. So derivative of cosine t, in the second row, we will write the derivatives of the first and the second column. So cosine t, it changes into negative sine t, and sine t derivative is cosine t. Then we use our formula to find the determinant AD minus BC. So cosine t times cosine t, it will gives me cosine square t minus BC, that means sine t times negative sine t. So sine t gives me sine square t, and since there is a negative sign, so negative becomes positive. And this is the trigonometric identity according to which sine square t plus cosine square t equals to 1. Now find out the Vronsky 1. That means the first column will be replaced. First column, first row always be replaced by 0. And the first column, second row will be replaced by the right hand side equation. That is your 10t. Means the original question right side is 10t, so we will write here 10t. Now the second column stay the same, that means the y2 values and its derivative. Again AD minus BC, so anything multiplied by 0 is 0, I am not writing, minus BC, that means sine t times tangent t. Now sine t and sine t, I can write it in the more simplified form. Tangent t, I know that it is equals to sine over cosine. So I can write here negative sine t times sine t gives me sine square t over cosine t. This will help me later on. Now I have W2. So in order to find the W2, I replaced my second column with the 0 and tangent t, whereas my first column stay as it is. That means cosine t and negative sine t. These are the values of y1 and its derivative. Again, I will use AD minus BC. So AD, it means it is cos t tangent t. And BC is 0, so anything multiplied by 0 is 0. Now I will write in the proper way cosine t. Tangent can be written as sine over cosine. And I can see that cosine and cosine cancel, so I have been left with only sine t. Now I know I have to find out u1 prime and u2 prime. So u1 prime is w1 over w. My W1 is minus sine square t over cosine t, and W is 1. So I'm not writing here 1. Now take the antiderivative of this thing. So I will get U1 equals to antiderivative of sine square over cosine t. Let me check it. So here we have to take the antiderivative of u1. So first of all, try to solve it. We know that we know about our identity, that is sine squared theta plus cosine squared theta equals to 1. So in order to find here, if I bring it here, it becomes negative sine squared theta. And if I bring the 1 here, so I will get cos squared theta minus 1. So using this identity, I will try to solve this equation. So I will write here u1 is equal to antiderivative of, in place of minus sine square t, I will write here cosine square t minus 1 all upon, that is cosine t and dt. Now, with all the numerators, write down the denominator to write in the simpler form. So I can write here as cosine square t over cosine t minus 1 over cosine t dt. Now this square will cancel with this one. So I will get over here 1 over, only cosine t minus 1 over cosine t, I can write it as secant of t and then dt. Now antiderivative of cosine is sine t minus antiderivative of secant t is ln of secant t plus tangent t. So this is my u1. Now come to the other side, u2 prime, that is w2 over w. We already know that w2 is sine t and w is 1. So taking the antiderivative here, we will get here antiderivative of sine t dt. Now this is the direct formula, that is sine changes into negative cosine t. Now we know that y particular, it is equals to u1 y1 plus u2 y2. So our u1, so over here, let me write here, okay, let me write on this side. So our u1 is sine t minus ln of secant t plus tangent t, and y1 is cosine of cosine t, okay, plus u2, which is negative cosine t. So let me erase this. So u2 is negative cosine t and y2 is sine t. Now open the bracket for this one. We will get here sine t cosine t minus cosine t ln of secant t plus tangent t minus cosine t sine t. Now minus cosine t sine t and cosine t sine t will be cancelled out, so only left with negative cosine t ln of secant t plus tangent t. So now write down our final answer. That means y equals to yc plus yp, and yc is c1 cosine t plus c2 cosine t and minus cosine ln of secant t plus tangent t. So just remember that practice always makes the man perfect. So keep practicing more and more questions to be fluent in these kind of questions.